In 6.6, now we're going to have absolute values again, but this time with inequalities showing up. So here we're told to solve an absolute value inequality, and in these first ones they're breaking it apart for us towards less than relationships. Solve each. Now, if this were homework in a book, we'd rewrite the original equation, where we have the absolute value of t plus 5 is less than 9. And just like before, we'll have a positive and a negative case, which means that either t plus 5 is less than 9, or its negative case is less than 9. Now, in the other ones, we would have just made this negative, but there's a small difference here. In parentheses, I'm going to write t plus 5, and that has to be less than 9, but it could also be negative. Now here's the reason that we put the negative on this side in these problems and not on the right side in the other ones. Let's focus on this one first. I'm multiplying everything by -1, and when I multiply this by -1, the negative on the left goes away, and I now have that that is greater than a -9. So it actually changes the direction of the symbol. So if you think you'll always remember to change the symbol on these and make the other side negative, you can figure your own way to do this, and that's fine by me. But either way, make sure you have your own way of figuring these out. So here's subtracting 5, and then we'd have t is greater than -14. So that's a little bit strange, but let's check it out. Let's check out -14 when I plug it in. -14 plus 5 is -9. Okay, so we have our absolute value of -9 becoming 9. That works out for me. Okay, now if it has to be greater than -14, let's think about that. Well, a number that's greater than -14 is, -13. So -13 plus 5 is -8, and the absolute value of -8 is 8. Now, if you happen to be thinking that like a billion also works, well, there's probably going to be a limitation on that. So let's see what happens when we do the positive side of this too. So I'll subtract 5, and I'll get t is less than 4. Well, this deal is that we're dealing with kind of an and situation now. It's not an or situation. And that means that -14 is less than t is less than 4. So when I'm talking about that solution set, that's what we're dealing with, -14 up to 4. So let's try 0 out, just because we know 0 is in the middle of that. Well, 0 plus 5 gives me 5, and that is less than 9. And pause this to give yourself a chance to try a couple other numbers too. We're told to graph the solution set, and if I want to think, well, -15 is over here, and then 5 is over here, that's going to limit the amount of space I use, and the steps in between would involve -10, -5, 0, and then 5, which means there are going to be 4 breakups there. So I'll cut this in half, and then half those halves. By the way, that's a practiced decision that I'm making, not something that you want to be like, oh, how do you do that? Well, it's pretty practiced. So if you're taking a couple minutes to figure that out, that's fine. And then I'm going to shade this in. This is not an equal to deal, so it would be from -14 all the way up to 4, both with open circles, and then you'd shade it in between so that it's clear that you're shading it and not your number line. It's always nice to kind of check a higher value out. Look at 6. 6 is just a little bit past the boundary. Well, if I did 6 plus 5, I'd get 11, and the absolute value of 11 would be 11. There's a lot going on there, so let's be thorough in our explanation of problem 2 as well. 2. The absolute value of x plus 2 is less than -1. And while I'm thinking about numbers that are less than -1, well, -2 is and -3 is, and slow your roll. You got to remember that anything in an absolute value bracket is always going to turn out positive, so you'll never get something that is less than -1. You'll also never get something that is less than 0 for this. So rather than write some lengthy explanation, we're going to write no solution. Okay, let's be thorough in the third one too. N minus 8 is less than or equal to 2. Okay, this one, it's a positive number, so we will have something work out. But basically this means we're probably dealing with whatever is in here is going to range between -2 and 2. So we'll do our positive case, our negative case, and then in the positive situation, we'll do this one first. We did the negative side first last time, but we did that because it was the exception to kind of talk about to introduce the new rule. Adding 8 to both sides gives me n is less than or equal to 10. And if I plug 10 back in, 10 minus 8 does give me 2. If I plug 9 in, 9 minus 8 does give me 1. And notice that I'm not talking as much about the extreme values now, and that's because of that whole and situation, where they might work in one and not the other. Okay, so here's a negative situation. The negative value of n minus 8 also has to be less than or equal to 2. Now if you wanted to, you could clear these parentheses and distribute. I'm choosing not to do that. So now I'm going to make this n minus 8, change the direction of the sign, and in my head I know I just multiplied that by -2. If you don't think you'll remember that, show a times -1 and a times -1. Divided by -1 also works, but that's a little bit more paper that gets used up. Adding 8 to both sides gives us n is greater than or equal to positive 6. And if I try to write this in one single line of math, I would say 6 is less than or equal to n is less than or equal to 10. And there's some thought that goes into deciding that that's in the middle. And then maybe you have to slow down to think about what that would look like in the opposite direction. Okay, because here it does get switched. I'm seeing 7 as a value that works. So 7 minus 8 gives me -1. Absolute value of that is 1, and that is less than 2. So I think this works out just fine. We still haven't finished the problem, so we will show a line here. I'm thinking 5 and 10 are good enough. 6, 7, 8, 9. And then I'm going to have this between 6 and 10 with closed circles and everything shaded in between. So that gives us our answer, and this is how we would write it in one line of math where everything's together. Number 4. Make number 4 a OYO problem, and I will put the answer up in just a second. Hopefully you put no solution. We'll stop this video here to give you some time to work on those if you'd like, or if you're feeling confident, move on to the next.